Okay, good morning. Can you please first of all get out your IB data booklet? Pause. Welcome back. Okay, so today we're looking at another way of calculating enthalpies for reactions, but this time we're using bond enthalpies, or more specifically average bond enthalpies, and you'll find those in table 10 of your booklet. So turn there now. Okay, this question asks us to calculate the enthalpy change of combustion of propane 1-ol. So I'm going to start by writing out an equation for that process. CH3, CH2, CH2OH plus oxygen, giving us carbon dioxide and water. If I balance that, I get 3 carbon dioxide, 4 water, so I need 3 oxygen. And we're trying to find the enthalpy change for that reaction. We'll call it combustion. Well, the enthalpy change for reactions comes from the energy difference between the bonds that have been broken and the bonds that have been made. So one easy way to find enthalpies for reactions is just to break apart the molecules and put them back together again in the reactants, in the products. So it's good if we know what the structures look like to see what the bonds are. So start by drawing out the structural formula for each of the reactants and each of the products. It doesn't have to be a Lewis structure with all of the lone pairs, but that would work as well. Oxygen with a double bond, carbon dioxide with double bonds, there's 3 of those, and water, I've got 4 of those. Don't forget the coefficients. Okay, so then we're going to break all of the bonds in the reactants. So breaking bonds. Well, I've got carbon-carbon bonds to break, but I've just got 2 carbon-carbons bonds to break. Even though there are 3 carbons, there's just 2 carbon-carbon bonds. There's a carbon-oxygen bond. So 1 carbon-oxygen bond. Got an oxygen-hydrogen bond. 1 oxygen-hydrogen bond. I've got 1, 2, 3, 4, 5, 6, 7 carbon-hydrogen bonds. That's everything broken in the propane 1-ol. And then I've got 3 oxygen-oxygen double bonds. 3 oxygen double bonds. If I go now and look in your data booklet and table 10, and you'll find, I hope, the following values. Gives me twice times 3, 4, 7. 1 times 3, 5, 8. 1 times 4, 6, 4. 7 times 4, 1, 3. And 3 times 4, 9, 8. Now please make sure you can find those yourself, because there are single oxygen-oxygen bonds, for instance, and double oxygen-oxygen bonds. There are single carbon-oxygen and double carbon-oxygen, so you need to choose the correct ones. Now add those all up and you get 5,901 kilojoules. And remember, bond breaking is an endothermic process, so that's a positive value. Okay, moving on to the products. And so now we are making bonds, which, by the way, is exothermic. So we are making two bonds there, the carbon double bond oxygen, but there's three of those. 3 multiplied by 2 gives me 6, so I've got 6 carbon oxygen double bonds, and in water I've got 2 OH bonds per molecule, but I've got 4 molecules, so 4 2s give me 8 oxygen hydrogen bonds. Check that up in your data booklet now with me, and you'll see that that gives us 6 times 7, 4, 6, 8 times 4, 6, 4. If I add those all up, I get 8, 1, 8, 8, and they're exothermic, so I'm going to make that negative. Okay, and then the enthalpy change of reaction, or for this example combustion, is just the sum of those. So the plus 5901, subtract the 8188, which gives me negative 2287 kilojoules per mole. So I've calculated the enthalpy change for my reaction using average bond enthalpies. Okay, now the next question up here says, have a look in the IB data booklet to see what they give for the enthalpy change of combustion. And if you look in table 12, it gives you the enthalpy change of combustion as negative 2021 kilojoules per mole. And we've got negative 2287. Now why are they so different? Two reasons here. The first reason is that the bond enthalpies we've used are average bond enthalpies. Individual bonds in individual molecules have slightly different values. For instance, the carbon-hydrogen bond exists in hundreds of thousands of different molecules. So we don't list its actual bond energy value for every bond in every molecule that contains a carbon-hydrogen. Instead, we find the average value of the same kind of bond in lots of different molecules. So that's true for all of the bond enthalpies here. They're all average values. So that will give us a slightly different value from one calculated using, for instance, enthalpies of formation. But the other reason here, which is perhaps more noticeable, is the fact that this is an enthalpy change of combustion, and if you remember, that refers to 1 mole of the substance, look at the board here, in their standard state, so the liquid, that's a gas, and this is being produced as a gas, and this is a liquid. However, the other thing about average bond enthalpies is that they refer to bonds being broken in the gaseous state. Well, because we've got liquid alcohol and liquid water being produced, calculating the enthalpy change using average bond enthalpies which have been found in the gaseous state is going to be slightly wrong. Okay, it's going to give us a slight error, and that's why we've got two different values. Okay, hope that helped. Thanks very much. Good night.